All right, so arcs and chords, they give you a description above this theorem here. It says the endpoints of a chord are also endpoints of an arc. If you trace the waffle that they give you here on the pattern and fold along the diameter, you will see they match exactly. So a chord, which we talked about in the very first section, has both of the endpoints on the circle, and those make up an arc. So for example, that they have right here, AB is a chord, and then it creates the arc AB, all right? The theorem says in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if AB is congruent to DC, then the piece of the circle that they cut out, that arc, would be congruent to the other arc. If the chords are congruent, the arcs that they create are congruent, right? And they give the proof here. You're given the circle and these two arcs that are congruent, and then they use corresponding angles are congruent. They use that the radii of a circle are congruent, so then they side angle side, and then they show you that the chords themselves must also be congruent. You will not have to prove it, but that is what the proof looks like. Some more terminology here. The chords of adjacent arcs can form a polygon. This quadrilateral that they have, ABCD, is inscribed polygon because all of the vertices lie on the circle. Inscribed means that all of the vertices lie on the circle. Circle C is circumscribed about the polygon because it contains all the vertices of the polygon. So this example that they've given us, we have circle E and we have polygon ABCD. The polygon is inscribed in the circle, which means the circle circumscribes the polygon. Those are the two terms. All right, inscribed polygons. The main veins of a snowflake can create 6 congruent central angles. Determine whether the hexagon containing the flake is regular. And so they tell us in this given piece, they're actually telling us that angle 1 is congruent to angle 2 congruent. They're telling you these are congruent, all right? If these are congruent, then the arc that they create are congruent, right? Those are congruent as well. And so if these are congruent arcs, we just found out from the theorem that congruent arcs are only formed by congruent chords. So if KL is congruent to LM, then the chord that makes those up, KL, is congruent to LM. All right? The next thing that makes up this polygon here are these radii. Those are all congruent. So you have all congruent sides, which means you have a regular polygon, congruent sides. All right? And so this inscribed polygon, because these angles that create it are all congruent, then the chords that they create are also congruent. So that must be regular. It must be regular here. And if you were to try to figure out what those angles are, you could just divide by that 360 there. All right, let's look at the next theorem. Bottom of page 537. In a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. All right, so if a diameter or a radius is perpendicular, so forms right angles with this chord, then it bisects the chord and it also bisects the arc. So that means TU is congruent to UV and it means TA is congruent to AV. So if these are perpendicular, it bisects it. If it's perpendicular, then it bisects it. So let's look at how this is used. Top of page 538. Top of page 538. Radius perpendicular to a chord. Circle O has a radius of 13 inches. Radius OB is perpendicular to chord CD, which is 24 inches long. All right? So they have told us that the radius is 13 inches. So this radius is 13 inches here. And I will write it darker because that did not show up. 13 inches. And then they have also told us that the chord C to D is 24 inches. So 24 inches for that. They want us to find CB, all right? CB. They want us to find this arc. It says if CD, this entire arc, is 134, that's the length. The length is 134. then find the measure of CB. Our theorem just said, if it's perpendicular, what does it do to the arc?
It's bisects.
Cuts it in half. So that means if the entire arc is 134, C to B should be exactly half. All right, exactly half, which is 67. All right, 67 inches to be specific. All right, 67. All right, find OX. Now, here's the deal. They want us to find from O to X. They did not say that the chord bisects the radius. They said the radius bisects the chord, okay? So they did not tell us that CD bisects OB. They told us OB bisects CD. There's a difference. So we can assume that from C to X is 12 and X to D is 12 because that is bisected. But we cannot assume that this one right here is cut in half of that 13. All right? So we're going to use the information that we do know to figure out that length. So we know that this length right here is 12. Why do I know that? Because the entire thing is 24, right? And this right here bisects it. So I know that just this piece right here is 12. Everybody see that? I know this is a right angle. How do I know that's a right angle? It bisects it, right? It told me on the other side that it was a right angle, and those are vertical angles. So even if I didn't know that, if once you have perpendiculars that forms all four right angles, I can make some assumptions. But perpendicular lines will form four right angles. So I can assume that that one is a right angle. What about O to C? O to C. Do I know anything about that line? What is OC?
Hypotenuse.
Okay, what does it compare on the circle?
A radius.
Did they not tell me a radius? They did. What's my radius? What's O to B?
13.
So if O to B is 13, what is O to C?
13.
13. So in this right triangle that they have given me, right, this beautiful right triangle, I know 13 and I know 12. They want me to find O to X. What are they trying to find? A leg of a right triangle. If you can't do this in your sleep, right, I don't know what to tell you. Right triangle, we have a leg and a hypotenuse. What theorem are we going to use? Pythagorean theorem. So 12 squared plus, we'll just say b squared equals 13 squared. 144 plus b squared equals 169. We have b squared equals 25. How long is b? 5. So O to X equals 5. Circle O has a radius of 10. AB, which is the chord, is also length 10. And the measure of the arc A to B is 60. Find the measure of the arc AY. We know that that is perpendicular based on the picture that they gave us. So we know that it cuts it in half. So you should have gotten 30 there. A to X. That is the chord, half of the chord, because it's perpendicular, cuts that in half as well. So you should have gotten 5 there. And then for O to X, you should have had to use the Pythagorean theorem. We know the radius is 10, so my hypotenuse would have been 10 here. We know A to X is what I just solved for, 5. So 5 squared plus B squared equals 10 squared. And when you solve that and simplify it, you get 5 squared, 3. If you put that in the calculator, here you would have gotten square root of 75 in your calculators, if you put it in your calculator and rounded. Right. Top of page 539. In a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Equidistant means, as it sounds, the same distance, right? Equal distances. So what they're saying is if you have two chords that are exact same length from the center of the circle, they will be the same length as well. All right, that's true, and it's if and only if. So it's true if then and the inverse of that, or converse of that rather. So chords AC and DF are equidistant from the center. What did they just tell us by telling us that information? That they are the same length, right? By telling us they are equidistant, they just told us they were the same length. If the radius of circle G is 26, find AC and DE. They actually told us the distance from the center, because you would have to know the distance to solve this one. And so they gave us the distance as 10. So we know that both of these chords are 10 units away from the center of the circle. We know the radius is 26, all right? So how then do we find the length of the chord itself? So then how do I know that this is a perpendicular? They didn't tell me it's perpendicular, did they?
Mm.
All right, so let's say,
Perpendicular line.
so let's say I have this line and I have this point. I can draw many, many lines, right? However, if I go here, is that the distance between there? No, the distance by definition is going to be a perpendicular. So when they told us this distance away, they automatically told us that it was perpendicular. Okay, so by telling us that is the distance, they told us that is the perpendicular. All right, so it is information they gave us by telling us that that was the distance from the point to the chord. Because if it was not perpendicular, that would not be the distance between those two. That would be the length between the chord that they, or the line that they drew.
And we know that.
But because they said that they were 10 units away from the center, okay? So if they're 10 units away from the center, they meant a perpendicular line from the center to the chord is 10. That's what they told us by telling us the distance, okay? So we know that's a perpendicular. We know the radius is 26, right? We have 26, 10, and yes, we're going to use Pythagorean theorem. So we're going to say 10 squared plus the one that we do not know is going to equal 26 squared. All right, so we're going to say 10 squared plus the one that half of the one that we're trying to find equals 26 squared. So this will give us this information right here, right? It'll give us that piece of that right there. When we do this, we're going to say 100 then plus my x squared, whatever it is, 576, x squared, or if we take the square root rather, is it 676? 676, I jumped to my, and then that's 24 squared. All right, so we know that this is 24. We have a 10, 24, 26 triangle. They want the entire length of the chords, which are the same length because they're the same distance. We found half of the length, didn't we?
Yes.
How do we know it's half of the length? Because if that is perpendicular, it cuts it in half. We just figured that out, right? So then the total length from A to C and from F to D should equal what?
48.
48. Oh. AB. From A to B should be double the length from Q to E, which is 40.
Yes, sir.
PE is Pythagorean theorem. 10 squared of 5, if rounded to the nearest tenth, is 22.4 actually. They rounded to 2 places.
Can we give it to the
All right, the last one. A yield sign is an equilateral triangle. Equilateral means what?
60?
It means each length is equal, right?
In each angle.
All right, I don't care about the angles of that, but we'll get to that, okay? But yes, it means angles and sides are all equal. If this chord is congruent to this chord, which is congruent to this chord, that means the arcs that are formed, right, are also congruent, correct? Mm-hmm. So there are 3 congruent in the entire circle. It wants the measure of each arc of the circle, and so the measure of the arc, and they're talking about by angle because we can't obviously do length. We don't have the length to do that. How many degrees are in the entire circle?
300.
How many arcs make up this one? 3, right? And they're all equal, so 360 divided by 3, right? So you should have gotten 120.